This video will cover the topic, evaluating an exponential function that models a real-world situation.
I've evaluated functions that model real-world situations before, but not for exponential functions. Can we look at an example of what problems under this topic look like?
That sounds like a good idea. Let's go through how to solve a problem under this topic, like this one. The dollar value, v of t, of a certain car model that is t years old is given by the following exponential function. V of t equals 26,000 times 0.86 raised to the t. Find the initial value of the car and the value after 12 years. Round your answers to the nearest dollar as necessary. The problem wants us to answer two questions. What is the initial value of the car? And what is the value of the car after 12 years? Let's start with finding the initial value. Do you know what the problem means when they ask for the initial value?
Well, I know that the word initial has to do with the beginning of something, right?
You're correct. When they ask for the initial value, they're asking for the value of the car in the very beginning, before any time has passed. We've already been given a function that will tell us the value of the car based off how old it is, so we need to choose an input that will give us the car's initial value. If the input t in this function stands for how many years old a car is, then what would the value of t be when the car is brand new and no time has passed?
Wouldn't it be 0 then, because the car is brand new, making it 0 years old?
Exactly. We know the input that will give us the initial value of the car, so let's plug our input in and solve for the answer. When we plug 0 in for t, we get v of 0 equals 26,000 times 0.86 raised to the 0. Any number raised to the 0 power is equal to 1, so we can simplify this to v of 0 equals 26,000 times 1. Since v of t represents the dollar value of a certain car model, we know that the initial value of the car is $26,000. The next part of the problem wants us to find the value of the car after it is 12 years old. Why don't you try to guide us through how to solve this part?
Okay, for the last problem, we had to use a value of t that would give us the initial value of the car, which was 0. This time, they want us to find the value of the car when it's 12 years old, so we need to have t equals 12. We can use the input 12 in our function to get the problem v of 12 equals 26,000 times 0.86 to the 12th. When we use a calculator to solve for the output, we get 4,255.5. The problem said we needed to round to the nearest dollar, so that means that the value of the car when it's 12 years old must be 4,256. Just to double check, when solving problems like this, you are choosing and plugging in inputs that will give you the output that matches what the question is asking. Like in this case, how we made the input 0 to find the initial value of the car, and then the input 12 to find the value of a 12-year-old car.
You're right. That means our two answers for the question are 26,000 and 4,256. It seems like you have a decent understanding on evaluating an exponential function that models a real-world situation.